The sixth episode of Python object-oriented programming series is called Getters and Setters, and this means we are going to learn about how to control the access level for the attributes that you want to create in your classes. That's going to be extremely interesting because we only learned about regular attributes that are always accessible from the class and as well as from the instance of a class. But what if we want to control the level of access, say that we only want to limit it from inside the class? So that's going to be very interesting to take a look at, and we are going to learn about different decorators that are going to allow us to control the access level for our attributes. So this episode will start by reorganizing our project a bit to make it more readable, and then we are going to straightforward dive into the getters and setters topic. So if by any chance that's your first time on my channel, then welcome. And if you will enjoy the content of this video, please make sure to hit the thumbs up button so we will spread this video to more people. Let's get started. Okay, so before diving into the topic of that episode, then we're gonna need to do some code organization in here, because as you can see, for each of the child classes that we will go ahead and create in the future to extend this project, then we're gonna need to do this in the main.py file, because that was the only single file that we were working with. And now that our project grows, we need to start working with multiple files. So that's why maybe working with a file that will represent the class of item and working with a separate file that will represent the phone child class will be a better idea. So we will have the main.py file dedicated for only creating instances of those classes. So let's get started with this. So I'm going to go to the project directory and create two Python files. First one will be named item.py. The other one should be named phone.py. And I'm going to take the code from our item class, and I'm just going to grab everything like the following, and I'm going to cut this, and then I'm going to paste this inside of that. Now pay attention that I use the CSV library, so that's actually the location that I need this library. So I'm going to just copy the import line, and that should be good enough. Now I'm going to do the same process for the phone.py, and I'm going to be copying this into the phone.py file as well. But now this file needs to import the item class, because as you can see we got an error here. So we should say from item import item like the following, and the errors should be gone. And then in the main.py file, we can basically use this file to only instantiate instances, meaning creating data that will represent something to Python. So this means that we can go ahead and import the class from the item file. We can do the same from the phone file, and then we can go ahead and do the stuff that we used to do. So we can say item.instantiate from CSV, and to verify that this works, we can also say print item.all like that. And if we want to run this file now to see that this works, then we can do that, and you can see that everything works just as expected. Now, just a quick side note, I'm not going to rely too much on the child class that we have created in the latest episode. To show the problems that we're going to solve in that episode, I'm going to rely more on the item class, so that it will be easier to follow and we will not complex things too much. Now that doesn't mean that I do not recommend using child classes or something like that, but it will be just easier to show you the cases that I'm going to show in the parent class. So that's why, for example, I deleted temporarily the import line of the phone class, and I just came up with a random item instance that name is my item, and the price happened to be that number. I did not specify quantity because we have a default value. And now after this line, you can see that I override this attribute by the string of other item. Now the expected result is not going to surprise anyone, because we see other item when we print this attribute. But we might want to ask ourselves, is that the behavior that we always want? What if we want to restrict our users to change the attribute of name once the name has been set up in the initialization, meaning in that line? Well, that's something that we might want to achieve for critical attributes like the name of your instances, and in our case the name of our item. So what we could do, we could actually go ahead and create read-only so-called attributes, meaning that we have only one opportunity to set the name of our item, and then we cannot touch the value of that anymore. So what that means? It means that we can set up this in the initialization, and we should have errors if we try to override the value of that. Now that's also known as encapsulation when we talk about the principles of object-oriented programming, which I will be focusing more on the future episodes. But now let's go ahead and see how we can come up with read-only attributes, how we can restrict our users to override the attributes after the initialization of our instances. Okay, so on the left side we have the main.py file, and on the right side we have the item.py file, which we are going to work on, and inside the class I'm going to create our first read-only attribute. Now the way that you can start doing this is by first using a decorator. And if you remember from the previous episodes, decorators are like functions that you can pre-execute before another function. So I could go ahead and use the property decorator and then go ahead and create a function, and here's the exact location that I could set up the name of our read-only attribute. So for testing reasons, let's go ahead and call this read-only name, something in that kind, alright? And then I will open up and close parentheses, and this will obviously receive self because it's going to be belong to each of the instances. And now for testing purposes, let's only go ahead and return a random string like a 3 times, alright? And then, now that we have done this, I can go to our main.py file and try to access this property. Now pay attention that I'm going to call those properties and not attributes. So I'm going to go here and I'm going to try to print item1.name. And now that I have wrote name, pay attention to the differences in this dropdown. For read-only name, we receive a totally different icon here on the left side, which stands for a property, where in here we see the F letter, which stands for a regular field. So if I was to try to print that and run our program, then obviously we will receive the expected result. But if I was to try to set a new value for the read-only name, say that we want to change this to something like that, then you're gonna see that PyCharm is going to complain about this. And even if we try to execute that, then we will end up with an exception that says attribute error can't set attribute. So that is how read-only attributes, so-called, are working in Python. You can create those by using a property decorator before your functions and return whatever value you'd like to return. Now the biggest challenge here is going to be converting the name attribute that we actually have, which is happen to be exactly here, into being a read-only attribute, and that is going to be a little bit challenging, but let's go ahead and start working on that. So first things first, I'm going to delete those 3 lines because we are not going to use this property anymore, and I'm going to scroll up a bit and work underneath this constructor here. So you might think that converting the name attribute into being read-only, meaning a property, is as easy as doing something like first using the property decorator and then go ahead and say def name, then receive self as the parameter, and then use something like return self.name because we already have the self.name assigned to the self object. But actually doing something like this is like saying to that class, hey, from now on you are going to have a name attribute that is going to be read only. And that is straightforward the effect of the property decorator. So I'm going to leave a comment here that is going to look like the following. But if you remember, we try to set the self.name into a new value inside our constructor. So you can see that this action is illegal because we have a read-only property here. So when you go ahead and create a property with the name of basically name, then you are no more allowed to set this value anymore. You are only allowed to have access to see this back in whatever instance you will create. So that is why if I was to hover my mouse here, then we're gonna see an error that is saying property name cannot be set. So the Pythonic way to doing this workaround to get over this is using one underscore before the name of our actual attribute name that we assign to the self object. And by doing this, we earn a couple of things that are quite important. So first, let me add here an underscore and just use something like that. And then now I need to go to my property function, meaning the property attribute, and I'm gonna need to add here the double underscore as well. Because first things first, I go ahead and set up the value for my single underscore name into being equal to the value of this parameter here. And then I go ahead and use one more read-only attribute that I intentionally give the name of name, and then I return self.underscore name. Now I can go back to my main.py file and see what effects those lines are having right now on our instances. So first, I can go ahead and set a name for my item, and I can access to the name of this item by saying something like item1.name. So I don't really have to go ahead and use item1.underscore name, because that is going to be a little bit ugly and not convenient, because accessing attributes with always an underscore before is not nice for each of the instances that you look to access to their attributes. Doing this one time inside the class is going to make it okay, but trying to access those attributes outside of your class, meaning from the instances, is not going to turn it into too much pretty. So that is the best way to overcome such a thing. And now if I was to try to print that, then, excuse me, let me fix that quickly, by item1.name and run our program, then you can see that that is working. And now let's go ahead and also see if we can set our name into being equal to another thing like that. See if that works. You can see that I cannot set that attribute. But however, I can still see this underscore name from the instance level. And that is maybe something that you look to avoid. It could have been a lot nicer if we could somehow prevent totally the access from this underscore name in here. So the way that this is achievable is by adding one more underscore to the attribute name. Now this might remind you something that is called private attribute if you are familiar with programming languages like Java or C#. That is pretty much the same behavior of using the private keyword before your attributes in those kind of programming languages, where it has different principles when it comes to object-oriented programming. So to sum up, if you add one more underscore to your attribute names, meaning you use double underscore, then you basically prevent the access to those attributes totally outside of the class. So let's see a simulation of that. So I'm going to minimize the terminal and I'm going to go to my item.py file. And besides using here single underscore, I'm going to add one more. And then I'm going to change this to double underscore as well. And now if we were to go to our main.py file and let's use here item1 dot and try to basically use double underscore and try to access to name. Now you can see that I don't even have an auto completion from my dropdown because I don't have access to see this attribute from the instance level. And that is something that you look to achieve when you want to have a clean read-only attribute, and that is the way that you can do that. So if I was to try to print this, then that's just going to complain about how it does not have the attribute of double underscore name in this instance. And again, if I was to remove those double underscores, then I will just access it as a property, meaning as a read-only attribute, and that is exactly what I look to have here. Alright, so now that we got the idea of that, then we still might be curious about how to set a new value for the name attribute. Now obviously using the property decorator is going to turn this into being a read-only attribute, but there are still some decorators that will allow you to, however, set a new value for this property of name. So let's see how that is achievable. So obviously that is not going to work because it says can't set attribute. So what we can do is we can use a new method where we can declare that we'd like to also set a new value for this attribute that we named name. So the way that that's going to work is by going to our class here and using here one more method with a special decorator. Now this decorator is going to look like the following. So I'm going to refer to the name because that's the property name, and then I'm going to use the dot setter. So by doing this, then I basically say, hey, so I still want to set a new value for that name, although that is a property, meaning a read-only attribute. So now if I was to go down and say something like def name, and this would receive self, and as well as one additional parameter, because the additional parameter should refer to the new value that I want to set to that name. So I will receive a parameter that I could name something like value, and then inside here I'm only going to set the new value for our double underscore name, because if you remember, when an instance tries to see the value of name, then we basically return self.double underscore name. So when a user will try to set the name again to a new value, then it should execute self.name equals to value. And by doing this, I basically allow our users to yet set a new value for name. So now let's show what effect those three lines are going to have in our main.py. You can see that now the error's gone. I can now go down here and use print item1.name, and that's going to work. You can see that I have other item. So this means not only I can set a new value for my underscore name, so-called, in the initialization, I can also do that later on if I only use this convention in here. Now those getters and setters thing are always confusing in no matter programming language you work, so I will do a final summary of all what we have learned until this point. Alright, so using add property will basically give you a control of what you'd like to do when you get an attribute. And also by using this, then you basically convert this attribute into being read-only if I was not implemented these setters in here. So you can see that now when I commented those out, then this line is going to have some problems, because by not doing this, then I basically say that, hey, name is read-only, you cannot set that. But if I was to again uncomment those back, then I will have the control to set this attribute to whatever attribute I'd like to. Now by using this statement here, basically getting the attribute, then I basically call the bunch of codes that are being executed in here. So whenever I use item1.name, then Python says to itself, okay, you try to get that attribute. So I will go ahead and try to execute all the lines of codes that are here. So that is what exactly happening here. And to show you that, then I can just use a random print function here that will say you are trying to get name like that, then you should see this line being printed right before what the actual value is, because at first we print you are trying to print the name, and then we return the self.underscore name, so it prints that over here. So that is what's happening when you try to get an attribute. But when you try to set an attribute, then Python says to itself, okay, so here you try to set an attribute. So because you set an attribute, then I should go ahead and execute the code that is inside here, because that is the setter of that attribute. So that is why when you go ahead and use this decorator, then you should always receive a parameter, because the other item is going to be passed as an argument to that parameter. It is very important to understand that. And that is why I can only allow myself to use one line of code that will say self.double underscore name is equal to the new value that you try to set. And to show you that, again, I can go here and say print you are trying to set. And this line should appear just before this print line, because at first I try to set a different value for name, and then I just print it back like that. Okay, so if I was to run that, then you can see that at first we see the line of you are trying to set, then right after it we actually see whatever item1.name is equal to. Now the reason that the value is set, it is because we set it over here, and then the next time I try to get the value, then those lines are getting executed. So that is the life cycle of getters and setters, and that is the way that it works. By having the control of whatever you'd like to do when you set a new value, you can also restrict it. You can go ahead and do some conditioning, or you can go ahead and raise some exceptions if you don't like the value that you receive. Let's say that you want to restrict the length of the characters for the name of that attribute, alright? So that is something that you can do. You can actually go here and say if len of the value is greater than 10, then you'd like to raise exception that will say something like the name is too long, something like that. And then you can say else, and then you can execute the line that will be responsible to set that value. So intentionally I'm going to leave it as it is because the length of that is 9 characters. So we should not have any errors. But if I was to add here 2 more characters like that and execute it, then you can see that we are going to receive an exception that will say the name is too long. So that's how getters and setters are working in Python. You now have all the knowledge that you need to play around with the different attributes and manage them the way that you would like to. So I believe that after the information that you received in that episode, you have everything that you need to manage your attributes successfully and play around with it, and as well as coming up with rich classes that will have multiple attributes, and then you can set up special behaviors to those attributes, and also you can decide that you'd not like to force to receive those attributes in the constructor. You can decide that you can delete some parameters in your constructor, and you can say that you will not like to assign those to the self object immediately when you create an instance. So whatever you would like to, you have all the tools to play around with how to manage your attributes. So I hope you enjoyed in that episode, and I hope the information was not too much confusing, and I hope that you will hit the like button after watching this video, and as well as subscribing to my channel, and I will see you in the next episode.